In the last video, we found an example project on the MPLAB Xpress example browser. Now we're going to spend a minute understanding the project that we've opened, and MCC can be quite useful for that. We're going to look through the application level code, and then we're going to use MCC to modify the project, in this case adding a UART to it and redirecting standard IO to printf, and then in main we'll add a printf statement to display the result. So we can see that this is definitely an MCC generated project, and so let's open MCC. Here's the resource management page of MCC, and for example we can click on the ADC. By opening MCC we can understand the configuration of these peripherals more easily. So for example we can see that the ADC is right aligned. We could see that in the code by going to projects, MCC generated files, adc.c, and in the navigator here looking for the initialization function, and here we can see the setup of the ADC, and ADFM is right, means that this is right aligned. So what is happening here, we can see in get conversion, if we click here, that we return, and what do we return? An ADC result type, which is a uint16. So essentially what's happening here is the high byte, which is 8-bit value, is being shifted left 8 so that we have the high 8 bits of the 16-bit result and then the low byte. Then in low duty value, so this is essentially the ADC 10-bit result. So we're taking the top 2 bits and the bottom 6 bits, shifting them right 2 so that we have the most significant 8 bits of our ADC result, which is essentially an 8-bit ADC value. So if we wanted an 8-bit ADC value, we could use this. Okay, but what we're wanting to do, going back to the home page of the MPLAB Xpress IDE, we can see that there's a link to the schematics of the Xpress board. Here is our part number, and we have some TX and RX and RC0 and RC1. Also, if we went back to the developer help page on this board, note that there's a link to serial communication, and that also uses the Xpress board. And so scrolling down here, they add a UART and also reach the same conclusion with port C, TX and RX. Back to MCC's resource manager, I can add a UART, enable transmit, 9.6 is fine, redirect standard IO to UART, and now I'll be able to generate code. Now what we can expect here is that if the project is not that new, we can see that there's some differences in the generated code. We can just accept these, they should work. So in the pin manager we wanted to have port C0 and 1 as TX and RX respectively, and now we can generate code. So going back to our project, our main, we should now be able to add a printf. The ADC result is unsigned int slash new comma, and duty value is essentially our 10-bit ADC result. Okay, so let's export hex, program the kit, LED. Okay, our kit is programmed, and let's open the data visualizer, connect to, if we check COM10, we have a USB serial device, and we can connect. We have some results on our ADC. We can change this to a light theme, and yeah, so we have the basic project working. So using this project, there's another video where we go further and explore the different options available with MPLAB Data Visualizer and Visual Debugging. So we're looking at the CDC UART interface and what we can do over this.